In early 2024, astronomers detected a new object moving through space, Asteroid 2024 YR4. At first, it looked like just another small rock among the thousands discovered every year. But what made it different was its orbit. Calculations showed it would pass uncomfortably close to the moon's path. That single detail raised big questions. Could it hit? If it did, what kind of crater would it leave behind? Would Earth be affected at all? And most importantly, what can we learn from such a close encounter? Today, we'll explore the surprising story of Asteroid 2024 YR4. We'll see why scientists paid attention, what would happen if something like it struck the moon, and what this means for planetary defense and for us here on Earth. If 2024 YR4 or any asteroid of similar scale were to collide with the moon, the event would unfold very differently than it would on Earth. That's because the moon lacks the protective blanket of atmosphere that surrounds our planet. Here on Earth, friction with the air slows and burns smaller objects, producing bright meteors and preventing most of them from ever reaching the surface. On the moon, no such shield exists. Every rock that crosses its path slams directly into the ground. The immediate result of such an impact would be the creation of a brand new crater. Depending on the asteroid's size, speed, and angle of entry, the structure could span several hundred meters in diameter and reach impressive depths. For comparison, craters this size on the moon are common, but each new one is valuable because it provides a fresh record of a geological process that has shaped the lunar surface for billions of years. When the asteroid struck, enormous amounts of energy would be released in a fraction of a second. Rock at the impact site would vaporize, while material around it would be ejected outward at high speeds. Some debris would settle back down in rays around the crater, while the fastest fragments could escape the moon's weak gravity altogether, dispersing into space. From Earth, astronomers could potentially witness a bright flash as the collision occurred. Specialized telescopes already monitor the moon's night side for such flashes during meteor showers, but a larger impact would be especially visible and scientifically valuable. Instruments in lunar orbit, such as high-resolution cameras, would then document the aftermath, mapping the crater's shape, size, and the extent of ejecta. These observations would allow scientists to refine models of crater formation, which are used to interpret impact features not just on the moon, but also on Mars, Mercury, and countless other bodies. For Earth itself, the consequences would be negligible. While some debris might enter trajectories that bring it close to our planet, atmospheric entry would destroy nearly all fragments before they reached the ground. The only effect for us would be scientific, the opportunity to observe a natural experiment that cannot be recreated in laboratories on Earth. Earth and the moon have both been shaped in profound ways by collisions from space. Far from being random accidents, these encounters are natural processes that have influenced the course of planetary evolution and even the history of life itself. One of the most famous examples took place about 66 million years ago, when a roughly 10-kilometer asteroid struck what is now the Yucatan Peninsula in Mexico. The impact created the vast Chicxulub crater and unleashed global climate changes that marked the end of the dinosaurs. While devastating at the time, this event also opened new ecological niches that allowed mammals and eventually humans to rise. It was, in many ways, a turning point in Earth's story. The moon carries an even deeper reminder of cosmic forces at work. According to the leading hypothesis, it may have formed from a colossal collision early in solar system history. A Mars-sized body struck the young Earth, ejecting molten debris into orbit. Over time, that material coalesced to become the moon. If true, then the very existence of our celestial companion is the result of one of the greatest natural events the Earth has ever experienced. Such encounters are not just ancient history. In 1994, astronomers observed fragments of a comet Shoemaker-Levy 9 crashing into Jupiter. Each impact left a dark scar in the planet's atmosphere, some larger than Earth itself. For days, telescopes around the world recorded the aftermath, offering a dramatic proof that collisions remain ongoing in our dynamic solar system. Even smaller scale events can leave a mark. In 2013, a meteor about 20 meters across entered Earth's atmosphere over Chelyabinsk, Russia. It exploded high in the sky with the force of several hundred kilotons of TNT, creating a shock wave that shattered windows and injured over 1,000 people. Though tiny compared to the Chicxulub impactor, it served as a vivid reminder that space rocks of modest size can still affect our modern world. Taken together, these examples reveal two essential truths. First, impacts are an integral part of how planets and moons evolve. Second, studying them gives us the tools to understand both the risks they pose and the opportunities they provide for discovery. Every crater on the moon, every scar on Jupiter, every meteor that streaks across our skies is a lesson about the forces that shape the cosmos. And in that sense, the story of Asteroid 2024 YR4 becomes part of a much larger narrative, one that connects the history of worlds with our own search for knowledge and preparedness. When news outlets picked up on Asteroid 2024 YR4, some headlines floated a dramatic question. Should we destroy it before it hits the moon? The phrase was catchy, but it also created confusion. In reality, no space agency had plans to blow up 2024 YR4. The asteroid was never considered a real threat. Instead, the discussion became a thought experiment, an opportunity to talk about how humanity might respond if a truly hazardous object were discovered. This is where the field of planetary defense comes in. For decades, scientists and engineers have been studying ways to protect Earth from dangerous near-Earth objects. The goal isn't to stage Hollywood-style explosions. Instead, the focus is on gentle but effective methods of changing an asteroid's course. Think of it less as destroying and more as guiding. One proven approach is the kinetic impactor. This was demonstrated in 2022 by NASA's DART mission, which deliberately crashed a spacecraft into the small asteroid moonlet Dimorphos. The impact successfully altered its orbit, a historic first that showed deflection is possible with existing technology. Another method under consideration is the gravity tractor. In this concept, a spacecraft would fly alongside an asteroid for years, using its own gravitational pull to slowly tug the object onto a safer path. It's a subtle technique, but given enough warning time, it could be very effective. There are also discussions about nuclear devices, not to obliterate an asteroid, but to nudge it. By detonating a charge near the surface, the blast would vaporize material, creating thrust that alters the asteroid's trajectory. While more controversial, this method might be considered if a large object were discovered on a collision course with Earth and time was short. So why bring the moon into the conversation? In truth, the moon provides a convenient mental backdrop. Imagining a scenario where an asteroid might hit our nearest neighbor helps people visualize the stakes of planetary defense. But the real concern has always been Earth. The technologies under study are aimed at ensuring that one day, if a dangerous object truly does head our way, we'll have the means to prevent catastrophe. The conversation around 2024 YR4 was never about panic, it was about preparation. Every time an asteroid like this is discovered, it sparks discussion, testing our readiness and reminding us that planetary defense is not science fiction. It is a real, ongoing effort to safeguard our future. Asteroid 2024 YR4 poses no danger to Earth, but if it ever struck the moon, scientists would seize the chance to study the impact up close. Craters may be common, yet each one is a fresh page in the moon's story, and a reminder of the forces still shaping our solar system. That's why today's missions matter. NASA's Artemis program aims to return astronauts to the lunar surface, supported by orbiters already mapping every ridge and crater in a stunning detail. If a new impact occurred, we would have the tools to study it immediately, linking human exploration with real-time science. Future crews on the moon might even walk to the site, sampling fresh debris to answer questions no telescope alone can solve. So what could begin as a violent collision would end as a gift of knowledge, helping us understand not only the moon, but also the history of our own planet. And in that, there's a simple truth. Every strike from the cosmos carries a message, not of fear, but of discovery.